Class. On this video, we will talk about one of the inverse trigonometric function, that is the inverse function of cosine, cos to the power of 1 x. First, we consider the cosine function. We have known that the cosine function has the domain, that is the set of real numbers R, and the range. In Vietnamese, range means giá trị, and its range is the closed interval from -1 to 1, and it maps each real number x to cosine x. You can see the graph of cosine 0x y equals cosine x. You can see the graph cosine when x equals 0, the cosine has value 1. When x equals pi over 2, the cosine has value 0. When x equals pi, the cosine has value -1. And when x equals 3 pi over 2, the cosine has value 0. And then when x equals 2 pi, the cosine has value 1 again. And we have so. Yes, we know this. And of course, this is not the graph of the cosine function. To have this graph of cosine function, you just copy this part of curve and then using translator to change its place. And then we have the complete graph. That's all. Okay, etc. With this graph, you can see that the cosine function does not have the inverse function. It does not have the inverse function. Why I said so? Because you can see that when we draw a horizontal line, you can see that the horizontal line intersects with the graph of cosine function at infinite point. So of course the cosine function does not have inverse function. So how about cos to the power 1x? We often say that the inverse function of cosine, and now we say that the cosine function does not have the inverse function. Isn't it not good? But of course, the inverse function of cosine is not the inverse function of the cosine we have just considered here. It is the inverse function of a function modified from this cosine function. We also call this a cosine function, but it's not from R to the closed interval -1 to 1. It's from an interval I to the closed interval -1 to 1. And of course, it also maps x to the cosine of x. We will modify the cosine. We will modify this cosine function to a new cosine function, which have the range, with the range is not R, but a new interval I, so that the new function will have the inverse function. What we should do here is choose I. Choose the interval I. So what is I? You know that when a function is strictly monotonic on an interval I, it will have the inverse function on this interval. Monotonic. Yes. Monotonic. That means strictly increasing or strictly decreasing. Look in this graph. Monotonic or increasing or decreasing means that the graph is just slide out or it just go up. And you should choose an interval I. On this interval, the graph of the function is just come down or it just go up. And the value of cosine x lasts from -1 to 1. You can spend several seconds to think what is the interval I that you choose. Okay? I think we should choose this interval. You can see that in this part of the graph. This part of the graph just go down. And on this part of the graph, y doesn't mean cosine lasts from -1 to 1. So the interval which we choose is the interval corresponding with this part of graph. That means the closed interval from 0 to pi. So I will choose I is a closed interval from 0 to pi. 0 to pi, okay. And with I is a closed interval from 0 to pi, you have that the new cosine function has a graph just go down. In other words, strictly decreasing on this interval. So we have the new cosine function has the inverse function. And we call these inverse functions cosine -1. Of course, the new cosine function from the closed interval 0 pi to the closed interval -1 to 1. So its inverse functions must go from -1 to 1 to 0 pi. Yes. And now you can see that this is the domain of cos -1 and 0 pi is the range of cos -1 of the inverse function of cosine. And this function maps each element in the closed interval -1 to 1 to the value of the inverse function cosine at x. That means cosine to the power 1x. But we should give a formula for cos to the power 1x. So we let this value is y. And y must satisfy some condition so that we can find it. So which conditions will y satisfy? You know that f at f minus 1x equals s. So of course you know cos of cos to the power 1x equals x. And of course the value of the inverse function of cos at s is y. We have that here. And so we have the cosine of y equals s. Of course, y must satisfy this equation. And from this, we know that y must lie in the closed interval 0 pi. These are true conditions which help you to find y. Yes. In this video, we have just explained about the inverse function of cosine function. We have said about its domain about its range and its formula. If you have any question, please comment below the video. I will answer. Thank you for watching.